Hello again, everyone. You're joining us for another episode of Executive Platform's Blueprint Podcasters. My name is Jeff Mix. I'm head of content and research. My guest today is Michael Andrews of Applied Materials. We're going to be having a conversation about alarm management and what pharmaceutical manufacturers need to know. There's actually some exciting new stuff in the space that maybe is going to surprise some people. I'm really excited for this conversation. Michael, thank you so much for joining me today.
Welcome. Thanks for having me.
Why don't we start off by talking about what is new in the alarm management space, because I think it's an established thing, but people would be surprised what is new.
What is the way it's been typically done, right? Software vendors will create their software, and every piece of different software by different makers has their own kind of internal alarming capability that's unique to them. And in today's world, where we're trying to be more connected, put that data together, in these systems that have disconnected alarms aren't giving us enough information, right? So we're really looking to connect across that data, because alarm conditions that we seek or we care about might be happening in one system over here, your MES plus the DCS, and so a lot of times those systems don't talk to each other. They're not aware of each other. So we're really kind of pulling that data together and basically determining whether it's a real alarm or not, and helping really reduce a lot of the nuisance, but also giving more advanced alarming capability by combining all that data, and then combining it also with the analytics to kind of do some teasing out of whether the alarm condition is actually real or not. So we're really trying to reduce excessive nuisance alarms. And operators a typical plant might see an alarm every 2 to 3 seconds. So you can imagine that being able to respond to those and understand when you've got a full alarm page of things just blinking and going off, trying to understand what should I focus on. So our focus is using AI, ML, analytics, and really teasing out the failure and root cause, and focusing the operator who's running the equipment with information that is succinct and gives them that human-like decision support to fix the condition.
There's a lot of great stuff in there to expand on. Maybe where I want to start is, I do have a lot of conversations about making software talk to each other, and what you've said sounds incredibly valuable. Why isn't there already a system that is pooling all the alarms together?
I think there's been attempts to do this before, not the way that we approach it necessarily. I think that it's a very unique for a number of reasons. One of the big problems is semantics of the alarms, right? You've got one system that calls this high, another calls it critical, has a different nomenclature for alarms, and a lot of the approach in industry for alarm management has been to just try to remediate, figure out what's a nuisance and what's not. Well, the reality is some of those things that are a nuisance at certain times are not at other times, so they become relevant and irrelevant, right? So you need a smarter system that can intelligently assess the alarm and the condition. So the difference of what we're doing is we're basically taking that alarm when we do sense it, using these advanced techniques of decision trees and ML and AI, and teasing it out in its operational context. We're also taking that alarm, and we have the ability to put it through a workflow. So if it's a certain critical alarm for a quality parameter, we can ensure that a secondary person can review it, right, and before they close out the alarm. But we're also sending with that action plans, or prescriptive actions, we call them sometimes, which it's more than just an alarm. We're also telling you how to fix it, because we're using the analysis to let us narrow down maybe 200 different failure modes to, ideally 1, but sometimes it's 5, but we've really narrowed the field for the operator to focus on and say, go check these things, and then based on what they're telling us in the field, we will dispatch them new instructions. And so that's really kind of the crux of what we're doing, is we're sitting on top, so we don't have to change the validated systems. They don't have to be reconfigured. A lot of times these source systems, don't have the capability to give us all the information we need, right? They might just be running a process. They might not know what batch or what materials went into that batch. We're actually aggregating all that contextual information together, that labeled data, so that we can do a higher level discernment of that alarm.
This sounds like it must fit so perfectly into that idea of Pharma 4.0 and digital transformation. Can we talk about that?
Absolutely. That's the motivation, right? We're becoming more and more data, more and more connection, but really, some of the main tenets, there's a long list of things under Pharma 4.0, but is first about interoperability. You're a business, you make a piece of software, I am a business, I make a piece of software. In the old days, getting them to talk to each other and integrate and being interoperable was very difficult, very costly, very time-consuming. So really what we're about is making it, these systems talk to each other and not try to force your system to change, but having this semantic layer and logic layer and analytics that can do that work, for you. And it makes the system easier to own, easier to deploy.
Now, with that said, we're not just talking about eliminating the number of alarms, nuisance alarms in particular. There's more to it than that.
There is. It's really about the high-value alarm, right? You can imagine we talked about the number of alarms, one every 2 to 3 seconds in a standard facility. The ability to focus on those is difficult, right, for an operator or many operators, right? You've got people all over the floor. So it's not just about reducing those nuisance alarms. It's about those high-value ones, the ones that are going to be the most impactful. So really understanding when is an alarm might be something you should be concerned about. It's very early warning. Can you predict the trajectory for the failure versus the things that I should focus on here and now and can remedy? And then the things that need to be brought to attention and maybe like once a shift or a day or a week, we're looking at those correlation of those warning alarms for early predictors. So it's not the thing that you need to stop what you're doing and go react, but it's giving you that foresight that you have time to fix it. So like I said, not all the alarms are necessarily always a nuisance. We also do a lot of alarm clustering because a lot of times a condition happens and you get these ancillary alarms that cascade, and you get 20 alarms sometimes, and it's really only for one condition. It just starts to cause this ripple effect from other things that are connected to it. They start alarming. So it's kind of really hard to discern what is the real, what's really happening, when did it happen. And then the reason that they become a nuisance in a lot of the operators' minds is they turn it off today or they silence the alarm and nothing happened. But maybe they leave their shift and 6 hours later something happens, or these alarms are slowly developing. It's not just about happening once, it's about happening more and more frequently, faster and faster. So we're looking at analyzing all those different event conditions.
This sounds like it could be a really powerful tool for root cause analysis. I have to think this is something that is going to help people solve issues that even a trained operator might not spot.
Absolutely. It can be very difficult even for a very trained operator or an engineer or a process engineer. So one of the first things that we do when we're modeling is we're using like hybrid modeling, a combination of mechanistic, empirical, and then these data-driven models, is first trying to discern, is the issue the equipment or is it the process, right? Or is it human error, right? A lot of times it's about someone misoperating the equipment, and that can be very hard to detect. So first we try to figure out what is happening. So if you have an equipment engineer, they might know the equipment really well, right? And the condition to them might look like an equipment issue, but it could be being caused by the process and the way that we're running the equipment. We're running it too hard, we're choking down the pressure, the flow rate's going up, right? So really what we're using that layer is to do that root cause analysis and identify, is this a process issue? If it is a process issue, what is the issue? Is there not enough volume in the tank? Is the agitator being run a little bit to top speed, those kind of things, like really discerning that root cause, because ultimately the alarms are super valuable, but in most plants, people have kind of become numb to them, and they just are like, oh, alarms, right? But they're actually the most valuable information in the plant, right or wrong. When they're wrong, it gives you an opportunity to try to understand how the process is behaving in the equipment. So we really focus on that root cause analysis part of it, because ultimately just doing an alarm, if that's all we did, which is what most systems do today, it's not enough, right? You got to give me a little bit more information, right? Like, give me a video. Can you give me content to show me how to troubleshoot it, right? Equipment's complicated. I might not know every step to take. So we're giving them that guided action digitally, step by step, and we're giving them schematics of the equipment, line drawings, manuals, videos to support it, so that we can, we're a very visual age, right? We use YouTube. I mean, how often at your house, you run into an issue, you go to YouTube to try to see how to fix it, right? Because you're not maybe an expert on an HVAC system, but you can fix a lot of stuff just when you've got the right set of instructions. So if you can classify the issue and then disseminate or dispatch the right instructions, we're really shortening those impacts and getting the plant up and running and making sure it's not going to impact quality, I think, most of all.
So I guess I want to talk about the pharmaceutical industry sort of specifically, because lots of companies could have alarm management protocols, but this is a well-regulated space. Things need to be documented, things need to be done a certain way, there are rules, and I can almost see a system like this being an incredibly powerful add-on to that, because it is literally documenting what has happened and what we've done about it. Can we speak about that a little bit?
That's a great point. That is the kind of cherry on the top, that you've really got to make sure that you focus on the regulatory aspect. So one is, we're documenting the alarms. Almost every alarm system out there today, you acknowledge it. Maybe it lets you put in a comment and it's done, right? And it maybe doesn't even ask you, well, was the issue real? What happened? How did you fix it? Right? Because we look at this from the quality by design set forth by the FDA, that whole concept of, we design that quality in right from the beginning. So we're making sure that when an alarm happens, we're getting it to the right people, that if it needs review, like from a quality or regulatory standpoint, so if it's a regulatory parameter, we want that to maybe go to the supervisor and then to quality to ensure there was no impact, right? So it's really tying the bow around that, making sure that it's all well documented, very retrievable, digitized, historized, right? So that we have that compliance and documentation of how and what was done. And because we're labeling that data and the root causes, that really fits really nicely with the end of the QBD process, which is continuous improvement, right? Because I think really what the FDA and the other regulatory agencies around the world are looking for, if I go into a facility and it just doesn't have a lot of alarms, is that success? I think it's really about showing that things happen and how you use that information to improve the manufacturing, the quality of the products.
Now, I mean, any system, there's always going to be a gap or an opportunity to learn from a mistake. I wonder if we can talk a little bit about when things get missed and how an alarm system adapts to that.
Right, that's the problem people always ask us, right? So they said, no, that's great, but how do we feel confident that it's being dealt with? Well, we also, inside that workflow, have escalations. So if, let's say it doesn't get answered in 15 minutes, it gets re-enunciated to that group that's on the floor, and then maybe it gets escalated to the supervisor that might be in the building, plus whoever's on call. So we escalate if there's no response and it's not rectified. So we have logic that we build in to handle that so that it doesn't get missed. And permission levels, right? So you can only acknowledge it once, right, for your level, but there might be 3 levels of acknowledgement. So that's another concept you don't see in alarm systems, is multi-level acknowledgement based on the role of the people that need to see the alarm, that need to be made aware. So that's the whole point of making sure things don't get missed, is having that workflow and that escalation around the alarms.
Now, when I envision a system like this, and I remember at the very beginning you're saying this is about sort of taking all of the different disparate systems that have their own setup of alarms, getting them all to sort of talk on the same data and at the same time. I have to think integration is part of this conversation, because if this is going to be something that is agnostic and speaking to everyone, what does getting that to work look like? Like, that is a complicated process, I would think.
Not really. I think even with a lot of the modern software, back in the day it was harder, but that was the focus day one in building this, is this interoperability, this intercommunication with other systems. So we just have, like, out of the box, you a whole list of like standard protocols. So if it's OSI Pi or ODBC, OPC UA, REST API, these are great decoupled communication systems. So we can very quickly spin up a data connector, ping that system, and then start reading that data in. As a matter of fact, a lot of times we're actually already gathering alarm data in the first day.
Wow. So, I mean, that was going to be my next question is like, what is a realistic timeline? I can appreciate everyone's stories a little differently, but like, if I was a pharmaceutical manufacturer and I think this sounds great, what is like from the decision to move forward to actually getting it up and running, what does that look like?
So funny, this is an approach always done in software. We believe in push it out immediately, right? So we want to start gathering all those alarms. So we actually have buckets of alarms in a way, like we can bring them in and log them, but we don't enunciate them to the floor. So we can start gathering that data and looking at it and analyzing it. So really from day one, give us your alarms, don't try to make the perfect solution yet, let's look at the data. And so the data will start coming in and most, every facility knows their problem child, like alarms, right? So you can start building those as the system's collecting and starting to learn these other patterns and gathering that data. So really, belief is just release it day one, right? And then you create specific alarms with these rules and these escalations as you need them and as you can kind of rationalize what the alarm reasoning is, like should this be an alarm or shouldn't it, right? And kind of so you pull those in and then you just really build the system along the way. We use this technology originally from the semiconductor industry, which handles a typical fab plant running 5,000-7,000 pieces of machines and close to a lights out kind of situation, so mostly machine-to-machine communication and robots. We're talking about 1 million alarms a day it's handling. As you can imagine, just like in the pharma situation, that's a huge bunch of alarms that have to be handled. They have to be remediated. They have to be understood. So our whole approach was taking that technology and bringing it to pharma with that robustness and being able to keep the manufacturing moving and understanding things like impact, right? Like I just don't want to know this alarm happened because if I go to look back at it a month later, what was the impact of that alarm, right? So as we're gathering all that data, we can go back and look and learn from those alarms. And maybe one alarm seemed like a nuisance. We're still logging those alarms. We're not enunciating, and we can bring that alarm in if we start to find it's valuable. Maybe it's an early detector that was not understood when the system was first designed. So it's very easy for someone to just go in there and reconfigure that and set it up and start listening to that alarm.
I'm so pleased you mentioned the semiconductor space because I remember from other conversations I've had with some of your colleagues at Applied Materials, it's such a relevant industry to draw lessons from because there is a lot of similar things, but it's also a very foreign idea to a lot of people in the life sciences. They haven't worked in semiconductors. Let's talk about that working relationship. We brought in Applied Materials to help us set up this alarm system. Yeah. You're coming in with this outside expertise. What does the working relationship look like, and what are some of the things your partners can look forward to leveraging as they get this thing up and running?
Great. I love this story. I came from biotech, right? So I was on the floor, basically engineering, working on, projects, commissioning, reliability engineering, doing investigations. Was looking for something like this. First started with the analytics before the alarms and came across Applied Materials. I ended up going on board with them about 6 years ago and was really tasked with trying to adapt the semiconductor technology that had been so successful, right? And bring that to pharma. So that's been my 6 years, is to build the application that I wish I had when I was in manufacturing. And, it is very similar. Semiconductor, a couple decades ago was having the same problem with human error, with too much data, right? I mean, even back then, you can imagine they were having too much data to sift through. Some facilities had 100,000 SPC charts. It became unmanageable. So machine learning was actually really adopted in the semiconductor industry probably 2 decades ago, much before anyone else had been really buzzing about it. So they learned very quickly that they needed a better way. They needed to reduce the human error. They needed to do better automation, and they needed to be able to control the process from end to end. So a little bit different than the pharma industry, very similar, like, right, we're coming into this age where pharma is starting to adopt more and more digital technology, but there's still a lot of human aspects to the production, right, where people still have to do things manually. And that's okay, right? Like the way the system's designed, you can kind of crawl, walk, run, right? You can start to put these pieces in and then build them, and then as you get confidence or more automation, you can kind of fill in those gaps. That's why we try to digitize that information on the floor, because we know that there's stuff that operators are doing that isn't going to be electronically captured. So we want to capture that. We want to know what did they do, how did they fix it, these kind of things, so that we can do that analysis. And then, this is in the semiconductor industry, it's all integrated, the MES, the CMMS, the DCS, which it's not the same exact concept in semi, but it's close. But the scheduling system, the quality measurement system, they're all integrated. They're all working in tandem as one system, right? And that's the big difference. And that's where we need to get pharma to, right? Is this interconnection of those systems to get to Pharma 4.0 and eventually Pharma 5.0, right? Which will be coming down the road very soon as we start to see more automation, robotics, things like environmental concerns and being good stewards, health and safety too. This isn't just about products. I mean, it's about safety. Alarms also let us know when things aren't, a safe condition for people. And so we always kind of think of these aspects of controlling but being safe, right, environmentally, for the people, the safety of the patients, so the quality of the product. And the more that we can monitor that with a lot of layers of controls, right? I mean, that's what it is. I think a lot of people get scared. They think, well, all of a sudden this machine's going to be making this decision. Actually, what we're doing is we're adding in more and more layers of control and visibility and detectability, right? So we're bringing the risk of something going wrong, a contamination in a product or a less than ethical product is really what our focus is, bringing that all in. So, and a lot of that technology that we've done in the semiconductor industry, we believe is going to really help pharma get to the 4.0 where they need to be.
I know whenever anyone talks about a new tool, there is going to be that sort of concern. Is this going to take up a lot of my time? Is this going to take up a lot of my resources? Do I have to start enterprise-wide? Can I start with a pilot project? Walk us through that part of it.
Right. So that's really the motivation of the design of the software, was to kind of be the antithesis of that, right? Especially, my experience had always been with these kind of like monolithic applications that take sometimes a year or two or longer, 40 or 50 engineers to deploy, huge price tags, and that's just not the way that that we can really make impact, right? So the whole idea with SmartFactory RX was we can come in at a very small footprint, sometimes even just down to a laptop, doing local control on a unit operation or a line, and then scaling up, and starting very modularly, right? Just kind of picking out one piece at a time. What is the thing that's causing you the most pain today in manufacturing? Well, I'd say alarms, and the topic of today. So it is a big problem for a lot of customers. So we can kind of come in and focus on just data gathering and giving recommendations. It doesn't have to be this huge rollout. We're not tapping into your systems. You don't have to change the configuration of those validated systems. So very low cost of ownership, very the impact and the ability to create these alarm rules and templates and codes. A lot of times you just fill out an entire spreadsheet and just import it into the system, right? Like that, and all of a sudden it's starting to pull all those alarms in. So it's not about these huge price tag monolithic systems. You can start very small, very low cost, very low effort, interoperable, right? And making sure that people can get value out of it, because we're definitely in a time of some of the greatest software technology, right? I mean, the onslaught of the cloud and GPUs and all the semiconductor technology that has brought that computational power down to like your cell phone. We've got so much technology, but I think we've also learned that we don't have really time or the skills or the workforce to invest in learning a whole bunch of new things, right? I've got to know how to configure my automation system, my recipe system. It takes a lot of skill sets. So we're really focusing on things that are deployable by regular people, right? You don't have to, be a coder, or a developer or things that work for engineers that are mostly like a lot of our stuff is visual, blocks, kind of where you're not even really doing code. You're just dragging, dropping, connecting. And I think that's how people think, right? Well, a lot of people like to think very visually. So we really focused on scalability and coming in and helping customers with their immediate problem, not just selling them this huge thing that maybe they don't need right now. So that's kind of what our focus has been.
We've covered a lot of ground in this conversation. For people who have been listening, are there one or two key things you want to highlight for them that they maybe want to think about a little further after this episode is done?
Yes. I think since the topic's alarm management, let me hit the two on that, because I think that there's not been a facility that I've ever been in that alarms aren't an issue. And it's very overwhelming. You typically have an alarm remediation team that's constantly looking at alarms, trying to figure out what's the right setting for this alarm, what to turn on, what to turn off. So I think the takeaway there is you're not going to win like that. That's not it. It's the problem is too dynamic, right? Your processes change. Those alarms that you're trying to figure out a singular set point or threshold, well, your process comes up and it goes down. So now you got to figure out, okay, well, I only care about it here, and then I got to turn it off. You end up with this very complex trying to manage your alarms. And I say don't do it, The takeaway is you need an alarm system that is more intelligent. You need smarter alarms because trying to fight that battle point by point, you're just never going to do it.
For people who have been listening to this who might have a few questions, want to learn more, what is the best way to get in touch?
They can go to our website, and see the different product offerings in our platform, the different modules from scheduling, quality to, production control, smart maintenance, our different packages that we have. That's at applied-smartfactory.com/pharmaceutical. But we really service pharmaceutical, biotech, cell and gene, personalized medicine, continuous manufacturing. So we really kind of do that whole gamut of that.
So I encourage everyone who has been listening to this who maybe works in that space and is thinking, we have a lot of alarms going off in our facility. Yeah. I encourage you to visit that website. And I just want to say, Michael, thank you so much for your time. This has been great.
Great. Thank you very much for having me. Thanks. Bye.
You've been listening to another episode of Executive Platform's Blueprint Podcast Series. I've been Jeff Mix. Let's do it again soon.